This is where the geek in me gets to play. Whenever we have the in-studio demos, this is arguably one of my favorite. So take us through what we're looking at today, the TMINI platform and all the fundamental components of it, and then I've got some questions for you.
Absolutely, Joe. So this is the TMINI miniature robotic system for total knee replacements. I'll share with you kind of the differentiated features, but also my background was Stryker Mako. I launched Mako Total Knee. Great technology, but I'll share with you some of the things that I thought were refreshing and different about the system that made me excited to come over to Think Surgical and start this journey. But I think you'll start with, first thing with robotics is, what is the OR footprint? So here's what we're looking at, and what I'll try to do is talk about things that are similar to other systems on the market, because they all have some similar foundational pieces of the technology, and then what's different. So the first piece is we have one base station. This is touchscreen in the OR. It's draped for the surgeon to use. Whereas if you compare it to the other systems on the market, they generally have 2, if not 3 other components that have to come in. And the first thing that is similar to all systems is they have to have an optical tracking system, right, to track what's going on in the OR. And if we look at Think Surgical, this is the only platform that is overhead tracking.
Why is that important?
That's important for a couple things. So where you're standing right there, that is generally where a surgeon has an assistant or fellow or resident, someone that's helping them with the procedure. All of their systems have side line of sight, so it would be standing somewhere a couple feet over there in the OR. So what happens is with side line of sight, during critical parts of the procedure, you have to move out of the way and have to stop assisting the surgeon. So that's one piece. Second piece is OR space. So even though that camera system may be small and compact, it takes out a field of view, which is basically 50% of the operative field. So we really call it unconstrained in the OR. You have freedom of access, assistants can stand where they need. And that was a big thing with robotics, is you were changing the way the procedure was done. With TMINI, we're basically going back to staff the OR how you want, do your procedural workflow how you will. And one of the best things that we've seen is this kind of disappears into the background. You actually don't realize it's there because it's optimally placed over the field of view. Okay. So that's the optical tracking. The next big piece is the robot itself. So a lot of people say robots are big, they're cumbersome, they're in the OR. If you look at our TMINI system, this is our robot, so 7 pounds, handheld wireless. Makes about 690 plus pounds of other robots redundant at that point.
Yeah, we're not going to break an OR floor with this, are we?
Correct.
Yeah.
And another innovation from that is not only is it handheld wireless, so it keeps the tool in the surgeon's hand, but all of it comes in one single tray. So a lot of things with robotics, a lot of people talk about are standardization, scalability, reproducibility, but then you kind of lose sight of that when you have these big machines coming into the OR, right? With that one tray of instruments, that includes everything that's needed for a robotic procedure outside of the minimal sets of tools from a manual kit, because we're open platform, but the robot itself actually goes in that tray. So it's not sitting in a closet someplace, everything, and that's a pretty unique advantage that our engineering team, which was making a robot that could go through an autoclave and sterilization cycle and allows for scalability, versus wheeling a robot from room to room. You just bring in a tray and it's ready for the next case.
Wow, so my whole procedure is sitting here right now.
Correct. Outside of a few manual instruments that they need to surface the knee for the manual implant the surgeon has chosen for this procedure, but it's basically that, and some of our vendors can get that down to one tray of manual instruments. So you're talking about 2 total trays, whereas most of the robotic systems you're looking at minimum 2, if not 4 trays of instruments they have to bring in.
Right, and if I'm looking at a high volume center, which is 12, 15, 20 cases a day, that starts to matter.
Starts to matter, plus you talk about the other piece that I was really excited of, which is open platform. You now start talking about a hospital that has a Velis robot, a Rosa robot, a Mako robot. They have to have not only these base stations and robots in their storage closets, but they also then have to have those trays times 2 or 3 per case, and that starts to add up just to facilitate surgeon choice.
So how do you pull off all this technology with this small of a platform, with a smaller footprint, versus what we're looking at today? Take me through the science.
Yeah, so I think it's, this was a vision that Think's been working on since I was there. I was fortunate to come in at a time right when they were about to commercialize, get FDA clearance. And really the engineer behind it, Joel Zuhars, who's our VP of Innovation, he started with the question of what are surgeons trying to do, right? And if you look at a lot of the robotic platforms out there today, yes, they are heavy on tech, but it's so complex that it was foreign to a surgeon to have to adopt. And really, if you look at TMINI, and we'll show you in the demo, what it's trying to do is give you robotic precision where it matters, but then basically fit into the normal functionality and familiarity of a workflow that a surgeon chose to do. And if you talk to a lot of surgeons, most of them from our research don't really care what the end effector is, as long as it's accurate and reproducible to what they want and it's efficient, right? This whole thing of putting a saw on a robotic arm is foreign to a surgeon, one. And two, these are highly skilled carpenters. I don't mean that offensively, but they're there and they chose orthopedic surgery for a reason, and that's they wanted their hands to do this. So in some regards it's familiarity, but it's what they like to do from that perspective.
So when we're gonna, the power of this platform starts all the way in the pre-op planning, right?
Correct. And that's kind of a bifurcating thing in this industry, right? When Stryker Mako came out and then you had the rest of them come on, a lot of the competitors targeted the CT-based nature of it and said, oh, it's an extra hassle, you're not going to get it approved, and they went imageless, right, from that perspective. If you look at the market now today, that debate is pretty much shifting totally towards CT-based. So there are still imageless systems on the market. Ours is CT-based. That's one of the reasons I came here from Stryker. I believed in CT. And the benefit of this is what you'll see here is the surgeon, before the procedure, now with the other systems, they get to plan one implant. Right? Our system, we now have 10 implant partners or 10 implants available. So the surgeon picks the implant that they believe is best for the patient or meets their philosophy ahead of time. That's shown up here. Now the surgeon has the ability to change their sizing from that perspective. And then you can see this is full control from the surgeon. A lot of the other systems require a non-sterile robotic representative to run this and keep pace with the surgeon. This is fully draped and sterilized for the procedure. And you can see here the surgeon can move this in all 6 degrees of freedom, angulations, resections. You now have your transverse plane, right, where they can do rotation, they can do flexion and extension and slope.
And all that planning is taking place on here right now.
Correct. So there's an opportunity of, we have a pre-plan approval. So there's basically a base station that the surgeon sits down prior to going into the OR. That's called our T-plan. But then that same plan, same functionality is uploaded here intraoperatively. So most surgeons would say once they're comfortable through our very short learning curve of about 7 cases, they're doing most of this in the OR because they've input their preferences to us. So we're taking 95% of the lift out. They're making their changes. But in knee replacements, what you see is this is about fit, right, for the knee. What really takes place, and we'll show you later in the demo, is the intraoperative decision making they get when they actually have the knee in a range of motion and start to balance it from that perspective.
Yeah, take me there now.
Absolutely. So we'll do this. Surgeon agrees with the plan. We'll close that out, confirm. Then there's a few steps of the procedure that we have to do before we get to the intraoperative balancing. And that's one, all systems have arrays, right, to track the femoral and tibial bones separately. One slight nuance to ours, though, is we have active trackers. So there's a battery in the bottom of each of these. The reason active is important, so there are passive trackers on the market. The challenge with passive trackers is if you get any blood or surgical debris on them, even a speck, the optical tracking system can't see that, right? So that's one challenge for that. Two is passive trackers have lower speed of communication than active. And that'll be important when I show you TMINI. So we have active trackers here. Now I can't put my hand over it, but general surgical debris it can still communicate, and it's also going to increase our speed of communication to the device. But then we go into what we call registration, and this is the same for all systems. You have to basically do a registration of the femur and tibia separately. And one difference here is we have smart tools. So what you'll see here is when I place this tool in the field of view, it knows I want to do registration, so it takes the surgeon to that step. Other systems, right, someone has to click through to the next chapter and so forth. Other thing here, you can see it's kind of a pistol grip, right? Some of these have probes, people are doing a foot pedal. So you're trying to coordinate a foot motion with a hand motion to collect. All of this is in control of the surgeon's hand. So you can see here, I'm going to start to take these points. If a surgeon didn't like a point, press the button, goes back. So they have full control and autonomy to do this, which is different from most of the systems on the market. Now, one thing here, because we're CT-based, one of the advantages of CT-based is the system has the truth, which is the actual anatomy of the patient ahead of time. So if we were to take bad points, it's not going to give you a false positive, right? The CT acts as basically an accuracy guard, right, to say the points you take, did the virtual world of the CT scan match up to what you just gave me intraoperatively.
So you're taking these live data access points you're getting right now and it's checking it against the original CT.
Correct.
And that gives you a double confirmation.
Correct. And it was something we talked about earlier, right? Navigation, which was imageless, the old saying is garbage in, garbage out. So with navigation and imageless systems, if you take all the wrong points, all you're doing is giving it data. So if you give it bad data, it's going to continue. With the CT scan, if you give it bad data, it has an image to basically validate the data you gave to it to say, is this correct or not? And if those two don't match up, it won't let you proceed with the case.
How does my registration time on the Thing TMINI compare to the other competitors in the market?
The same.
Same.
Same from that perspective. Early on, we did a limited market release, purely on learning curve. We had surgeons do benchmark procedures of their standard of care. So some were manual, some were robotic. So there's a learning curve with anything, but what we basically found is between 5 to 10 cases, despite benchmark, manual or robotic, they were time neutral in that time frame. Okay. And this is another benefit of CT. So you mentioned I can now place this pointer here. We have a crosshair there.
Yep.
The surgeon can now say, okay, I've passed my registration. I'm 0 millimeters to the CT scan. So it's just the ability to then do a cross-reference check to make sure that our registration is good.
And that would have told me down there if I was out of sync on the registration.
Yeah, so like right now I'm hovering this over the bone. It shows 3 or 4 millimeters.
Got it.
Now we have a registration metric that won't let you go past a certain point, but this is another verification to say, does this pointer line up anatomically with what I'm seeing in the OR or on the patient? And then it also gives you a distance to say how close were you to that CT scan.
Got it.
Same thing here. Again, I can press and hold this button. It takes me to the next step of the procedure. So the smart tools are very helpful. Doesn't require a tech or someone to be knowledgeable of the surgeon's next step. It basically just says, okay, look, I put this tool under the field of view. The surgeon probably wants to do registration.
Got it. So that's your mouse.
Correct. It's a little bit better than a mouse, Joe, but I know what you're talking about.
I'm going way back. I'm going
right.
OG here.
That's right. So then we talked about earlier the intraoperative assessment, right? So what you're going to see on the screen is we have live knee here. Then these are key endpoints that surgeons want to measure. So extension is when your leg is straight, 0 to 20 degrees. Flexion is when your knee is bent, right, from that perspective. Best way I can give an analogy is it's like balancing the tires on your car, right? So there's 4 numbers that surgeons are looking at. There's a medial and lateral, so left or right side of your knee, and both standing and then in sitting from that perspective. So what you can see now is I bring this out into extension, and you're going to see the numbers on the screen there, Joe, on the left-hand side. See how that number opens up? So basically that's giving me tension or gap assessment values. So we do that in extension, and then flexion, same thing. We're going to stress it open. And what you'll see here is our system automatically captures the largest value seen there. So what they're trying to do is take a piece of metal and plastic that equals a certain height of millimeters, right? For this knee system, let's say it's 19 millimeters. So you need at least 19 millimeters to be able to fit that metal and plastic in. So it's giving the surgeon a baseline. Yes, we started on the initial plan of just planning it to the patient's bony anatomy. What we're now doing is fine-tune adjusting this to the patient's ligamentous anatomy. And so what we see here is, let's say our goal is 19 for today. We're slightly tight in extension. We're pretty good laterally in flexion and tight medially. So what we can do here is just to adjust our extension space, we'll play with our distal femur. So we raise that 1 millimeter. Now we have our 19s that we're looking for. And then here in flexion, there's a mismatch between lateral and medial. So what I can do is actually anchor on the lateral side. So that will keep my lateral resection the same, and then just rotate until we get to the 19. And there's a ton of different things here, right, that surgeons can look at. You can look at your flexion space, start to say, am I notching, overhanging? The surgeon can turn this view off, look at the bony anatomy, are the osteophytes, or different defects. I can just look at my resections to make sure I have a good resection base. So really anything the surgeon wants to do here, we are agnostic to implant, but also alignment philosophy. So really at this point, it is the surgeon's decision based on what they think is best for the patient in that specific case.
Which is what they want.
Correct, correct. And that's why we don't choose a preferred implant. We don't choose a preferred implant philosophy. We just really want to facilitate in a reproducible way of what they want for each patient. Okay. Any questions on that, Joe?
No, it's pretty clear.
Great.
UI UX is amazing.
The team did a really nice job on it. We've gotten a lot of compliments, and one of the things I think that's critical is we've seen a lot of these robotic systems of trying to put every single piece of information into the UI UX. And what we really try to do is say, what are the critical things that give you the most value, the 90 to 95%? Because robotics can be overwhelming, particularly if you're a surgeon coming from manual. You've never seen objective data like this. It was really feel and touch that they had. That can be overwhelming. So we try to, I don't want to say take away all the smarts and the features and everything, but we try to prioritize the ones that give the most value and make it simpler for these surgeons to adopt, not get lost in the data. So when we go there, We confirm ability for that. Now this is really where the magic happens, I think. And at first, you know, Stuart says this a lot. When he joined Think Surgical, he couldn't really think of what a robotic, handheld robot could be. And I had a preconceived condition that it had to be attached to a robotic arm, but it's now transferring the plan. That's why it's wireless. So this is two-way communication. What we're now going to do is use the robot for about a minute in the whole procedure. Okay. But what we're going to do here is you're going to see TMINI. I'm going to press this trigger, and what you're going to see is as I get closer to the plane of the plan, it adapts to my hand movement.
Oh, wow.
So that gives you proximal,
So that's right?
distal, angular, and it's only going to give the surgeon power when it's on plan.
When it's on plan. Wow. So if you're off plan, it stops. All right.
Yep. So here.
So it's got that same gating mentality that other robots who came before this guy.
Correct.
Right.
Correct. So you'll see here, I'm going to place one pin here on the distal femur. Take that out. Place the second pin here. And if you saw how quick that moves, it's instant feedback. That's why we have the active tracking. So that is the robotic piece.
That's
so
it.
Robotic precision. Now, we will do that 2 more times on the cusp distal femur and tibia. But this is where I talked about that comfortability of workflow. So now you place a cut block on a robotically placed plane based on the plan, and now it's manual execution that surgeons are used to. Surgeons know how to use pin drivers. This is a robotic pin driver, right? They know how to do that. Now you take that out, now they're just executing how they normally would. So it's a blend of, I think, robotics in the right areas, which is the surgeons want to execute their plan reproducibly and efficiently. And then you take the cumbersome nature out of some of these robotic devices. There's burr devices, there's haptic guidance, all these things. As long as it's accurate and efficient, the surgeons tend to like this workflow better. And you're only using the robot, as you just saw. If that's one of 3 planes we're doing it in,
That's it.
maybe a minute.
Wow, that's fascinating. And certainly a little mind-bending when you think about the form factors that are present in the marketplace today. Over-featured, maybe over-designed. So you started from a different place, which is really, really interesting. What are the other features in here now that we should probably talk about that we didn't?
Yeah, I think what I'll do is I'll show you one more of the pins, and that's because that distal femoral cut and proximal tibia, they're flat cuts. So for all of our implant manufacturers, that's the same workflow. That cut block comes in our set. But where we get into the 4-in-1, and I don't know if you saw, back to the surgeon having control. The surgeon with this button doesn't have to interact with the screen. They can scroll through the different cuts because some surgeons might like to go tibia first. But what we now do is, in a normal procedure, this would be a cut distal femur. You place that pin.
If you would have came off plane there after you went in and you created a little bit of a moment arm there, it would have stopped?
Would have stopped. Would have stopped. All right. And that's actually sometimes in the early user experience, the pin's not spinning, the surgeon thinks it's the device not working. But actually, that's the device protecting you from yourself at that point. So now this is specific. So we have this guide block, right? So every implant manufacturer has their own 4-in-1 cut blocks and so forth. So rather than placing those pins exactly where those 4-in-1 pegs go, we have this little disposable. So one for each of the implants that we have FDA cleared on our system. Simply slots over those 2 pins. The surgeon now drills a hole. That becomes the guide for the pegs on the 4-in-1 block. So it just sits in there. And because we know ahead of time what our size of the femur is, they have to bring in 1 4-in-1 block out of the array of 8, right? So size 4+ here. That's the only 4-in-1 block that they need. They do that, execute their cuts like they do manually. And one of the advantages there is, talk to a lot of surgeons, right? Some of these robotic systems that are calculating each plane separately. Each of those planes has its own error stack. Right? So if one's too distal, too proximal, then the other ones are on, then you don't have that cohesion of cuts. With this, we literally have one piece of error, right, which is in one plane. With the 4-in-1 now, all of those cuts are going to be co-located no matter how the first cut was. So there's a lot better cohesion versus calculating each of those planes differently.
Wow. Yeah, it's in a good way unsettling on when you think about a robot these days in orthopedics. This is not what comes to mind, but moving forward will for me.
Well, it's funny, actually. I think sometimes people say, well, that's not a robot. They say that's it, that's all that it does. But actually, if you really think about it, it's so simple that it's changing, like you said, the definition of robot. And I couldn't imagine it when I joined Think Surgical. I actually called Stuart when he talked to me, and he said, do you want to join? I said, well, I got to see it. And he's like, well, do you just trust me? And I said, well, you're going to have me lead upstream and downstream marketing. I need to see it from that perspective. But when I first saw it, the overhead tracker made a lot of sense. That made a ton of sense. I love CT-based, and then I was really excited about the open platform nature of it and what that could do for the industry.
Fantastic. Well, I appreciate you bringing this entire robot into 160 Studios. And the elevator was out, but we didn't need it.
That's right. Well, I can tell you, no one else can ship their robot through standard mail if they want to.
That's true.
So we can do that.
Thanks so much. I greatly appreciate it.
Joe, thanks so much.
You got it.
Appreciate it.